going to be bouncing back and forth between our two books that we're using. We have an older version of the book, and I'm using that copy. That's M2, page 131, where I'm located. If you're in the new copy of the book, it's on page 375. So just kind of get that out there for you. M2, 131. Or on the new book, page 375. But the point of this lesson that I'm recording for you is to talk about the graphs of something called reciprocal functions. And really, a reciprocal function just means whatever function you have, what would it look like if it was flipped? Like how you flip a fraction, like 1/4 has a reciprocal of 4/1 because you flip the values. When we can look at a whole range of these types of functions and talk about like what sort of information we have, then we're going to graph it and we're going to come up with like a picture of values. We're being nice to you in that you're probably going to need a calculator for this, right? It is Algebra 2, and get some decimals. Start with this whole concept of a couple of things, and I've also got some colors to highlight in the book as well when we come across it. We want to talk about the domain. So every time that domain comes up, I want to make sure that I'm bringing that to bear for you. Domain is usually our possible x choices. So in this case, the x row of -6, -5, -4, etc. And then in the other, it's actually one table just broken in two parts for printing on the paper, but it's meant to be one table. Although it's broken intelligently. Let's see if you can figure out why. Now, the x row usually is domain. So let's talk about it. If you have x as a input, and then you plug it into the function f of x equals x, the resulting value in this case is you just get back what you put in. Like a good even relationship. You get back what you put in, and then the more you put in, the more you get back. So if you put in a -6, you're going to get a -6 back, and so on for all the other x choices in our domain. The reciprocal function does the flip of that, though. Whatever x you put in, you get its reciprocal back. So I'm going to start actually over on this table. It'll be easier with the no negatives. Let me zoom in for a minute here. Okay, let's go. Okay. So I'm going to plug in a 1. I'm going to put it where x is, as in I'm going to get 1/1, because the 1 goes where x is, and it's now the bottom of the fraction. In the first case, for the f function, f goes into the function, 1 goes into the function, and 1 comes back out. So you get an answer of 1. Next row, 2, column, 2 goes into the function for f, and you get a 2 back. But when you put a 2 into this g function, the 2 goes where the x is, and it's on the bottom. So you're going to get 1/2, which is 0.5. Put in a 3, put in a 4, put in a 5, put in a 6. Reciprocal function does exactly that. It flips the fraction around. So when we have a reciprocal of something, we can graph the shape of like what its reciprocals would be relevant to it. And let's actually plot those on a graph. So we're going to plot 1, 1. Yo, it's right there. We're going to plot 2.5. So 2.5. And we're going to plot 3 1/3. I'm going to plot 4 first. I'm going to skip ahead for a minute. Because between these 2 points, the 1/3 exists between those 2 points because it's at the 3. It's got to be between the 1/2 and the 1/4. So not too tall, not too low. And the points just keep getting lower. In fact, let's go ahead and extend the table here for a second, because we're going to have to draw a smooth curve. And drawing a smooth curve, like, what's going on over here? Let's extend the table. Let's go out to, let's go with 1/2. So when you go to 1/2, in the x direction, you're going to put it in the bottom of the fraction, 1/1/2. The trick with these is you flip and multiply. So we're going to flip and we're going to go 2/1. That's the flip. Here's the multiply. So we're going to multiply the bottom. Those cancel. We're going to multiply the top. We get a 2. 1/2 goes to 2. 1/2 goes to 2. How about 1/3? In the moment, I'm thinking 1/3. Cool, that's nice. Let's go 1/4. So x is becoming 1/4. That's what the input domain choice allows you to do. And then you put a 1/4 where the x is for the g function. I'm ignoring f for a minute. It doesn't need to be there. So for g function, 1/4 goes on the bottom. 1/1/4. Now, flip and multiply means 4/1. There's the flip. You put it in the top and the bottom for balance. And then you multiply. So these will cross out because 4/4, 1 cancels. And then 1 times 4 is 4, as in 1/4 should have a height of 4. So 1/4 is half the distance to the goal, and then up to a height of 4. And you see what's happening here? This is actually creating this kind of like a sideways, like corner, like C shape. Something you cannot use, x cannot be 0. Because if you put a 0 on the bottom of a fraction, 1/0 is not, I repeat, not, do not call it 0. 1/0 is actually undefined. And the calculator says error. Hey Siri, what's 1 divided by 0?
The same as 2 divided by 0, undefined.
Yo, they juked us. So 2 divided by 0, 3 divided by 0, 4 divided by 0, it's undefined. You cannot divide by 0. So then what we actually end up getting is a picture of a graph that looks something like this. Smooth curve. It'll get really close to the y-axis, but it will not touch. So I know my pencil kind of strayed a little bit, but if you graph this, we should graph this in Desmos to look at it, you will actually not touch the y-axis. And it goes out this way too. It's getting closer and closer and closer. For some reason, it never actually touches the x-axis either. I wonder why. I wonder why. You should wonder why as well. Okay, and then solve that problem when it happens. Now, sketch it. In fact, it's not very visible. Let's bring in some color. There you go. That's the graph of these data points. Now, if we introduce a negative, what's going to happen? If we go to this side of the graph, what's going to happen? What's a -1 really going to do? Putting a -1 where x is for function g, you get 1/-1, which is, -1. 1 over, put a -2 into x for function g, you get -1/2. This is the exact same table, just with minus signs. So cheating, -1/3, -1/4, -1/5. Why'd the minus sign move into the front of the fraction? Shouldn't the minus sign be like on the bottom? It's true that actually that if you have a negative on the bottom of the fraction, that could be written out in front, or it could be written up in top. You just can't write negatives in both places. So you can put a negative underneath, because that's where it would go. But then it's the same as if you put it in the front or on the top. And honestly, don't ever do this. Don't ever put the negative on the bottom. Ever is a harsh absolute. Most of the time, don't put the negative on the bottom of the fraction. -1/6. We've got these points already plotted. They're these points. They're just over here. So -1/2, -1/3, -1/4, -1/5, -1/6. And the same thing when we get close. Like if I choose like -1/2 is going to go to -2. -1/4 is going to go to -4. So we're actually going to get this point and this point and this point. We're going to get closer to the y-axis in this case. We're never touching the y-axis though. All right, so I graphed the points here. I added these, right? I added these. The table has us plot these points. So connecting a smooth curve here never touches the x-axis for some reason. We wonders. Why? We wonders. Okay. And then graph it by drawing a smooth curve through it. And there you have it. This is our picture of a reciprocal function. The reciprocal function specifically, 1/x. Let's do some Desmos and just kind of like lock it in. For x. So 1/x. There it is. There's our curve. In fact, if you hit the gear and then you click on table, you can see the points that we were plotting. And 0 gets undefined. We can go -3. We can go -4. We can go -5. We're allowed to use like the negatives, but there it is. That's our picture of the reciprocal function. Ooh, I didn't show you fractions. Watch this, fractions. So 1/2. It puts a dot right here. The reciprocal of the reciprocal is the original function. And so that means that all of those values, they kind of like flip around. All right, let's bring it to a close here. Bring it to a close for the concept of reciprocal functions. Let's fill out that table down at the bottom. We have the reciprocal of -1. Put it in the function. -1 over 1 over -1. -1. Put in -1/2. Put it on the bottom of the fraction. It flips. It's the reciprocal of the reciprocal, but it's still negative. -10, -100. Does not exist. D and E. Okay. Thought you'd get us there, huh? I see you. We see you. 10, 2, and 1. All right. Ladies and gentlemen, there's way more to do for this concept. But just the idea of graphing rational functions, before I sign off and say that we are done trying to end the video for you, I do need to identify a couple of things. And if it happens now or it happens later on, this line, the fact that the graph never touches the line x equals 0, that's x equals 0 makes vertical lines. X equals 2, x equals 4, x equals whatever. Those will be vertical lines. So the vertical line x equals 0, we call that, and sounds like a swear word. It's not. Asymptote. There's like a P in there, so asymptote. You just blend over it. Asymptote. Also, there's another one. There's another asymptote here, and that's the line y equals 0. Those are two asymptotes, a vertical one and a horizontal one. Thank you for watching this video. There's more to follow. Maybe we'll do a little bit more of this in class. Take some notes, add your notes to this book, but transcribe them onto your own note page. And thanks for watching. See you later.